Today's topic is about force between two long parallel current carrying conductors. We are going to derive the expression for the force which acts between the two long parallel current carrying conductors. We will start the derivation now. Listen here, in this picture there is a conductor. That name of the conductor is called A, through which the current I1 passes. And here the magnetic field that is seen in the form of concentric circles. When current goes in the upward direction, as per right hand thumb rule, the direction of the magnetic field will be in the anti-clockwise direction. Here one point is there at point P. Here at point P the magnetic field strength is B1. Since current is I1, it can be taken as B1. The strength of the magnetic field that can be calculated by using this formula. Are you clear? So this is the strength of the magnetic field at point P. What is the formula? B1 vector is equal to mu naught I1 divided by 2 pi r minus I cap. It shows that this is acting as per the three-dimensional coordinate system. Look at that. Here it goes inside. It goes towards inside means it goes towards the blackboard. Therefore, the direction of the magnetic field is acting towards inside. So it shows that it is acting towards the negative x direction. Since it is acting towards negative x direction, we have to use the unit vector minus I cap. Are you clear? So why I1 is there? This is the magnetic field due to the strength of the current I1. That's why B1 vector is equal to mu naught I1 divided by 2 pi r minus I cap. Here the magnetic field is calculated at a distance r. That's why r is there. Are you clear? So this is the magnetic field strength here. This formula is obtained from Biot-Savart law. Are you clear? Now as per the title, we have to calculate the force between two straight conductors. Now I am going to draw another conductor. Are you clear? That name of the conductor is called B. So I have drawn exactly at point P and the name of the conductor is called B. Can you understand? Now there are two conductors. Now you have to assume that through the next conductor B, I2 amount of current is flowing. Are you clear? Now this is the current carrying conductor which is placed in the magnetic field of the first conductor. Understand this. This is the magnetic field due to this current. Now this current carrying conductor B which is placed in the magnetic field of the first conductor. Now who will experience the force? The conductor B will experience the force. Are you clear? The conductor B will experience a force. So magnetic Lorentz force will act on the current carrying conductor because current also flows and it is placed in the magnetic field of the first conductor. Therefore, we have to write the equation. Are you clear? So before that, I will tell you slight alteration to be done in the first formula. Here this minus sign that can be written in front and it can be written like this. Now, in this conductor B, you imagine a small element. That small element is called current element. Are you clear? That small element is called current element. I have drawn it separately. This entire wire that can be split into several segments. So here the small portion of the very small, infinitesimal small portion of the conductor can be taken as small element. So this portion we have to find out how much amount of force is acting, Lorentz force is acting. Are you clear? Now since it is a very small element, there a very little amount of force will be acting. No, the small amount of force which is experienced by B, that can be written like this. This is the fundamental formula. Look at that. DFB. What is DFB? Very small amount of force acting on the small element in B. Are you clear? In current carrying conductor B. That is called DFB. Since the strength of the force is very less, we can call it as DFB vector. This formula is arrived from the basic formula. What is the basic formula for Lorentz force? F vector is equal to ideal vector into B vector. This is the formula which is already derived in the previous concept. Now the same formula is written here. Instead of I, what should be written? The current passing through the second conductor B must be written I2 dl. Are you clear? So the second conductor is placed in the magnetic field of the first conductor. Therefore B1 must be written. So I2 dl vector into B1 vector, that one gives you the small amount of force which is exerted on B conductor, where it is acting in the small portion, in the small element. Are you clear? So that's why I have written here. Now what you have to do, in this B1, here one B1 is there, no? This B1 must be replaced by this equation. After replacing, look at the equation. Now dFB, what is dFB? Force, small amount of force exerted on the current element in B conductor is equal to, already I2 dl vector is there. That is acting in which direction? That is acting as per the diagram. That ideal which is acting in K. K means it is acting towards Z direction, positive Z direction. Are you clear? Because current is flowing in this direction. Look at that. Look at my finger. It is flowing in this direction. It is acting along positive Z direction. Therefore, K clear cap is written. Are you clear? K cap must be written here. And then into, instead of V1, substitute this equation. Mu naught I1 divided by 2 pi r minus I cap must be written. Now in the next step, this K cap and I cap both can be written together. Are you clear? So look at that. dFB vector is equal to this minus sign that can be brought in front. Minus mu naught I1 I2 dl, 2 pi r is in the down denominator, 2 pi r is written. This K cap and R cap both can be written together. Are you clear? So finally this equation you will get. This K cap and R K cap into R cap, that one become J cap. Are you clear? So minus mu naught I1 I2 dl divided by 2 pi r. What that J cap indicates? J cap, it indicates that the small force exerted on the small element in B, that is acting towards which direction? Y direction. It is acting in the Y direction. Are you clear? That's why this is written as J cap. Minus J cap is there. Since it is minus J cap, it shows that it is acting in the negative Y direction. It is acting in the negative Y direction. So negative Y direction means we can write like this. This is acting in this direction. Look at that. This is positive Y direction. This is the negative Y direction. Therefore, this dF vector, dF force acting on B, it is acting in the negative Y direction. That's why minus J cap is there. Are you clear? Now, look at that very important one. Now, so far the force is measured only in the small element. Now we have to calculate the force per unit length. What is this? Force per unit length. Now we have to consider, look at the diagram. In this entire wire, let us take a unit length. Unit length means the length of it's a lengthy wire, infinitely lengthy wire. In this you have to take on 1 meter length. So within this 1 meter length, unit length, we have to calculate how much amount of force is acting. Are you clear? So by the time when you calculate it for unit length, this dFB will disappear. If all small elements are added, this is dl, no? dl1, dl2, dl3, dl4, if all unit small elements are added, you will get the unit length. Now we have to calculate the force acting on the unit length. Unit length within which small elements are there. If all of them are added, you will get the unit length. So dFB, it becomes FB vector, which is equal to, instead of dl we can write it as L, because the length of this portion is how much? L. Therefore instead of dl you can write it as L, and J cap is there. So this is the formula for force acting on the unit length. That is also acting in the direction of minus Y direction. Since it is acting in the negative Y direction, minus J cap is there. Are you clear? Now here we are going to calculate the force per unit length. What is this? Force per unit length. We have to calculate in each unit length how much amount of force is acting. So for that purpose we are using this equation. What is this? F by L, force acting per unit length. This L can be brought down. If the L is cross multiplied, you will get force acting per unit length in B conductor can be calculated. What is the formula? Minus mu naught I1 I2 divided by 2 pi r j cap. Are you clear? So this much amount of force is acting in B in each unit length of the wire. That's why this equation is written. Are you clear? Now we are going to place the A conductor in the field of the B conductor. As we have seen earlier, we are going to derive the force acting on A. Already we have calculated the force acting on the B conductor. Now we are going to derive the expression for force acting on the A conductor. So look at the diagram here. Here this is the B conductor through which I2 amount of current flows. When I2 amount of current flows, there will be a magnetic field. The shape of the magnetic field will be in the form of concentric circles. And here look at the diagram. Here the arrowheads are pointing towards you. They are all coming out of the blackboard. So as per the diagram, with the help of right hand thumb rule, it shows that the magnetic field is acting along which direction? Positive x direction. Are you clear? It is acting along the positive x direction. And imagine a point P. So we have to calculate the magnetic field at point P. Are you clear? So the strength of the magnetic field can be called as B2. So at a distance R, the point P is located. There you are going to calculate the magnetic field strength. So what will be the magnetic field strength at point P? So this is the magnetic field strength. What is B2? B2 is nothing but magnetic field at point P, that is located R distance from the conductor. Why I2 is written? This magnetic field due to the flow of the current I2. It is traveling in this direction. The direction of B2 is acting along x direction. That's why I vector is written. Are you clear? And it is acting in the positive x direction. Are you clear? Next one is here in this conductor. Here the conductor is there. Now we have to place the A conductor now. Are you clear? Now we have to place the A conductor in the field of the B conductor. Now I am going to draw the next conductor. Are you clear? Now the next conductor to be drawn. Now I am going to draw the next conductor that is placed in the field of B. Let us imagine through the conductor A, how much amount of current is flowing? I1 amount of current is flowing. Now A conductor is a current carrying conductor which is placed in the field of the B conductor. So what will happen? Here this conductor A will experience a Lorentz force. Are you clear? So in this conductor you have to imagine a small element. The length of the small element can be called as, what is this? DFA. Are you clear? This small element can be taken as DL, where small amount of force is acting. That small amount of force is experienced by A can be called as DFA. Again I will repeat, this is a small element. Here we can't draw. That's why this portion is magnified here. The small length can be called as DL. Here there will be a small Lorentz force is acting because this current carrying conductor is placed in the field of the second conductor. DFA. What is DFA? Force experienced by the first conductor. So what is the formula? As per Lorentz formula, Lorentz force formula, this is the formula. What is DFA? DFA is equal to, why A is written? Because the force is experienced by the A conductor. DFA vector is equal to I1 DL vector into B vector. Why I1? Because current passing through first conductor is I1. What is B2? B2 means the first conductor is placed in the field of the second conductor. So this first conductor, it is in the field of B2. That's why this is written. Now what we have to do? In the next step, we have to substitute B2. I1 DL is there, already B2 is there. This B2 to be substituted here. After substitution, you will get this equation. dFA vector is equal to I1 dl vector. Here I1 dl, it is acting along the z direction. Look at that, the current is traveling in this direction. Current is traveling, I1 is traveling in the direction. Look at the coordinate. Here it is acting along z. Therefore k cap is there. B2. That B2 to be substituted here. Well, instead of B2, what is the formula? Mu naught I2 divided by 2 pi r, I cap must be written. In the next step, this 2 can be combined now. So what is the equation? dFA vector, which is equal to mu naught I1 I2 dl. This k cap and I cap both can be written within the bracket. Are you clear? Now k cap into j cap, that one becomes j cap. So that is the next one. dFA vector is equal to mu naught I1 I2 dl divided by 2 pi r, k cap into I cap, that one becomes j cap. It shows that the force acting in the small element, that is acting along which direction? Y direction. Therefore the force dFA must be written in which direction? Y direction. That's why that j cap that indicates. Are you clear? Now very interesting one. Now in this conductor, A conductor, we have to imagine a unit length. Unit length means the length of the wire must be taken as unity, 1 meter, like that. Is it clear? Unit length is taken. There we have to calculate the force. So FA by L is nothing but force acting on the first conductor per unit length must be calculated. So here, now I am going to write FA. What is FA? Force acting on the first conductor, A conductor. So here, this is called small element dl. If so many dl's are there in this wire, dl, so many dl's are there. If all dl's are added, you will get unit length. Therefore, if all dl's are added, you will get L. The total length of the unit length you will get. Are you clear? So dFA is a small amount of force. FA is the greater amount of force which is acting in the unit length. Now per unit length you have to calculate. Force per unit length must be calculated. So this L can be brought down. If the L is brought down, what will happen? FA vector divided by L is equal to mu naught I1 I2 divided by 2 pi r j cap. Are you clear? This force per unit length which is acting in the first conductor, that one also acts along the direction of which direction? Y direction. That's why j cap is there. Are you clear? Look at the similarity in this equation and in this equation. Here second conductor experiencing a force. Here first conductor experiencing a force. Are you clear? Second conductor experiencing a force in this direction. First conductor experiencing a force in this direction. That's why the title is given as force acting between the two long parallel current carrying conductor. That is the title. So look at the expression, both are similar. Here the only change is, here the force is experienced by B conductor, here the force is experienced by A conductor. But the rest of the things are same. Mu naught I1 I2 divided by 2 pi r. Here also mu naught I1 I2 divided by 2 pi r. Everything is similar. Are you clear? So mutually in between the two wires, one force is acting in this direction, another force is acting in the direction. I will draw the force between these two. Are you clear? So look at that. Here the current is traveling in two conductors like this. This is A conductor, this is B conductor. Here one force is acting. That can be called as FA. Here another force is acting. Are you clear? This is called FB. So look at that. Both are acting, is clear, in the opposite direction. So both are trying to come closer. Any doubt in this? So when two conductors through which current is traveling in the same direction, both the two, they will get attracted with each other. They will come closer. Are you clear? If the current is traveling in the opposite direction, look at that. The current is traveling in the opposite direction. For example, in one conductor, current is traveling in this direction. In the another conductor, current is traveling in the opposite direction, means they can be called as I1, I2. So in this case, there will be a repulsive force. One force will be acting in this direction, another force will be acting in the opposite direction. Look at that. Here they are attracted with one another. Here they are repelled with one another. Everything that depends on the direction of flow of current. Okay. Thank you.